Petrified Forest National Park has a robust paleontology program that is in a constant state of new discovery. Keep watching to learn about new projects and ongoing research that are happening in our fossil preparation labs and collection. In 2017, a large fossil skull of a 225 million-year-old amphibian was collected from the field. And in the winter of 2020, our lab team opened the field jacket to begin important work removing rock from the specimen. This jacket was destined for the museum demonstration lab to be uncovered in real time for visitors to Petrified Forest. With each passing day, more of the bone was revealed, like these hockey puck-shaped vertebrae. It wasn't long until the skull was clearly visible. The holes where the eyes would have been located peered out into the 21st century. Eventually, all of the vertebrae and ribs were removed from the original field jacket, and the top of the skull was fully prepared under a microscope. The only thing left to complete was to flip the skull and remove the rock from the roof of the mouth. We created a temporary toilet paper, fiberglass, and plaster cradle to support the skull during the flipping and preparation process. Once hardened, the rock was removed using small needles and air scribe tools similar to mini jackhammers. The anatomy of the skull became more and more visible each day, including 2 rows of sharp teeth lining the tip of the snout. After 310 hours of preparation work, the skull and associated vertebrae and ribs were added to our museum collections, ready for researchers to study. In fact, in 2021, many researchers and students visited our museum collection to learn more about the late Triassic. Will Reyes, a graduate student at the University of Texas at Austin, spent his internship assisting with field operations in addition to learning how to create thin sections of fossil bone to examine things like internal bone tissues and structures, or paleohistology. The animal in question? The largest specimen of Paratypothorax ever collected. Paleohistology can tell us whether this individual was a full-grown adult when it died, or if it still had some growing to do. Paratypothorax was also the focus of visiting researcher Dr. Jeff Martz. He spent a few weeks on a redescription and review of the Paratypothorax material from the park. Jeff Martz, you may have already noticed, is also credited with many of the amazing animal illustrations and reconstructions, like this recently drawn skull of Phytosaur smilosukis, nicknamed Gumby. Elliott Armour Smith, a graduate student at the University of Washington, was delving into the Shuvosaur collection drawers as part of his summer internship. He's interested in studying bones, as well as bone thin sections, from this group of reptiles to better understand how they grew from adolescence to adulthood. He also worked with the NPS staff as well as students and staff from the University of Washington and the Burke Museum to collect additional specimens from the field. These days, a site called Thunderstorm Ridge has been holding the attention of NPS paleontology staff and seasonal paleontologist and PhD student at Virginia Tech, Ben Kligman.
The site is located near Blue Mesa and preserves a 221 million-year-old ecosystem situated at the margins of an ancient lake or pond. The discoveries they have made there are changing how we view late Triassic ecosystem diversity at Petrified Forest and around the world. So far, at least 54 different fossil species have been found at Thunderstorm Ridge, including several species of extinct reptile groups, bony fish, and some of the earliest fossils of amphibians, including frogs, salamanders, and caecilians. The site also preserves 11 new species of lizards, 1 new species of turtle, and 1 new species of an early mammal relative. Most of these new species are small-bodied due to the methods used to recover microvertebrate bones. Sediment from the site is collected, washed, and screened to separate out even the tiniest fossils. Paleontologists then look at the recovered specimens under the microscope to identify small bones, jaw fragments, and teeth. Thunderstorm Ridge has been especially important in understanding the evolution of lizards. Tiny lizard jaws that have been extremely well preserved show evidence for diverse feeding adaptations, including herbivory, carnivory, and omnivory. We can make exact copies of microfossils by 3D scanning and printing them. We can even print them in larger sizes to be able to look at features closely and use for education and museum exhibits. Researchers continue to make new discoveries from the site every year. Over 3,000 new specimens have been cataloged into the park collections, and so far, 4 manuscripts have been published in peer-reviewed journals, with many more that are sure to come. Thanks for following along, and we look forward to sharing these new discoveries with you soon.